Hello and welcome to another episode of TASC Mathematics. Today we're still continuing the series on the laws of exponents. However, this is the final law. We're looking at the quotient rule, and the quotient rule states if you have a base raised to an exponent and you're dividing by a matching base but raised to a different exponent, you keep your base and you subtract your exponents. Notice that it's m minus n. So notice I'm keeping my m and I'm subtracting the denominator exponent n. Now, my first example, I have 3 to the 5th divided by 3 to the 2nd. On the TASC test, they like to use numerals as their bases. Now, I know this is a base because I have an exponent. So the rule states keep your base, and I'm going to subtract my exponent. So it's 5 take away 2. So that's 3 to the 3rd power. Now, if you're on the test and you don't see 3 to the 3rd power, because your base is a numeral, you can evaluate it. 3 to the 3rd power means 3 times 3 times 3, which is 27. So if you were on the gridded response, you cannot enter 3 to the 3rd. You will be able to enter 27. However, if you're on the multiple choice and you don't see 3 to the 3rd, then you're going to have to evaluate to get an answer of 27. Now, a question I get in my classroom a lot is, will they have both answers on the test if it's multiple choice? The answer is no. You're going to have either 3 to the 3rd or 27, never both. Students like when their base is a variable, much easier. So I have x to the 8th divided by x to the 4th. My base is the x. I'm going to keep it, and I'm going to subtract my exponents. So that's 8 minus 4. So this will be x. 8 minus 4 is 4. Now, some of you are wondering, how did the mathematicians came up with subtracting the exponents? Now, x to the 8th is actually 8 x's. So that's x times x times x times x times x times x. How much do we have? 1, 2, 3, 4, 5, 6, 7. One more, 8. So x to the 8th means I need to write that the x is multiplying itself 8 times, and then I'm dividing by x to the 4th, which is x times x times x times x. And basically that means that this cancels, this cancels, this cancels, and that cancels. And what you're left with is just 4 x's multiplying each other. And to write that in a simpler form would be just a 1x raised to the 4th power. But, you know, in mathematics, they like to give ridiculous exponents sometimes, and you cannot write that out like so many times. Like this one is y to the 12th. No one has time for that. Okay, let's take a look at another example. So here I've included some coefficients. You always know coefficients from bases. Bases are raised to an exponent. Coefficients do not have an exponent on the outside. So I have 15y to the 12th divided by negative 3y to the 7. Now, whenever you're dividing, you always go to heaven. Always remember that little trick. When you divide, go to heaven. Now, because these are coefficients, you're going to divide. So, negative 3 goes into 15 negative 5 times. Now, the y's are your bases, so you're going to keep your base, which is your y, and you're going to subtract the exponents. 12 minus 7, so my answer is negative 5y to the 5th power. Now let's try another example, but I switched around the 15 and the negative 3. Now again, when we divide, we go to heaven. Now can 15 go into negative 3 evenly? The answer is no. So what you have here is a fraction, and the silent rule of fractions is you must always reduce. So since 15 can't divide negative 3, I'm going to have to reduce this. And I have to find a number that will divide 3 and 15 evenly, same number. Both numbers can be divided by 3. Negative 3 divided by 3 is negative 1, and 15 divided by 3 is 5. So notice my answer is negative 1/5. Remember, your base is y, and we're going to keep that, and we're going to subtract 12 minus 7. So my answer is negative 1/5 y to the 5th power. Notice the difference between this answer and this one. Now in the previous one, your denominator was smaller and could actually divide the 15. Now in my second problem here, my denominator is 15, which is bigger. So there's a difference when your denominator is smaller and bigger. Okay, so take a look. Sometimes they'll give you coefficients that can't actually be divided, so don't get scared. So here, 2 negatives gives a positive. When we divide, we go to heaven, but can 7 divide 12 evenly? The answer is no. Is there a number that would divide 12 and 7 evenly? The answer is yes, it's a 1. But if you divide by 1, you're going to get back 12 and 7. So the only thing we could have done here was to realize that 2 negatives gives a positive and 12 over 7 is in its simplest form. We're going to keep our base of x, but remember we need to subtract the exponents. We're also going to do the same thing with y, and that would be 14 take away 5, and the same thing for z. But please remember with the z, if you do not see an exponent, there's an invisible 1 there. So 3 minus 1. So my answer is 12 over 7, x to the 5th power, y to the 9th power, and z to the 2nd power. If you know your rule, you're okay. All they can do is to give you coefficients and a bunch of variables. Let's look at some other examples. So here I have 2 to the 4th divided by 2 to the 7. 2 is being used here as a base. The rule says keep your base, and remember it's 4 take away 7. And you get 2 to the negative 3. Now remember from previous episodes, negative exponents are not allowed. So when your answer turns out to be a negative exponent, we need to write that in the positive form. And remember the rule for negative exponents. If you have a base raised to a negative exponent, to write it in the positive form, we write the reciprocal. So that's 1 over 8m. So here, 2 to the negative third is actually 1 over 2 to the 3rd power. Now, if you don't see this as an answer choice on your TASC exam, because your base is a numeral, you can evaluate it. 2 to the 3rd power is 8. So your answer is 1 over 8. So on the gridded response, you would enter 1 over 8 because you can't enter an exponent on the grid. If it's multiple choice, you can have 1 over 2 to the 3rd. However, you will not have both. It's either or. 1 and 2/3 or 1 over 8. This one, more for your gridded. Multiple choice, you can have either or. Notice here, my base is a variable. Notice that with this x, I don't see an exponent, so there's an invisible 1. The bases match. Keep my base, and I'm going to subtract my exponents. 1 minus 10. 1 minus 10 is negative 9. Again, negative exponents are not allowed. So I'm going to write the reciprocal, which is 1 over x to the 9th. So last week I taught this in my night class, and with a night class, we have to do things to keep ourselves awake. So one of the things we did in class, and one of the things I said to make it a lighthearted class and we all had fun, is that whenever you see a negative, make a fraction. So to make a fraction, I put it over 1. Whenever you have a negative person in a relationship, because if you have a roommate relationship, then that person can't stay, you would have to evict them. So here you had the negative 9, and they had to be evicted to the denominator position. So they went to the denominator and became positive. Now when they left that space, you put a 1 in there. Okay, it can't be blank. You put a 1 to hold the space. Now let's take a look at another example. So here I have some coefficients and other variables. 2 negatives gives you a positive. When we divide, we go to heaven. 9 goes into 27 3 times. The x's match because we're dividing. So keep that base and subtract those exponents. And for the y, subtract those exponents. We end up with 3x to the 5th, y to the negative 3. Okay, this roommate situation is not going well. We need to evict someone. Remember, when you see the negative, make a fraction over 1. Who is getting evicted? It is the negative exponent. That person needs to go. So now the new roommate situation looks like 3x to the 5th, and the y to the 3rd is in the denominator position because they had to leave the apartment. So this is your answer, 3x to the 5th over y to the 3rd. Let's look at another example. So we have 32x to the negative 6, y to the 5th, z to the 9th, and I'm dividing by negative 8, x to the 9th, y, there's an invisible 1 there, and z to the 12th. So again, the coefficients will divide. A negative goes into a positive will give you a negative, and 8 goes into 32 4 times. My bases match for the x, but I'm going to subtract. That's going to be negative 6 take away 9. The y is going to be 5 take away 1, and the z is going to be 9 take away 12. Now I'm going to end up with negative 4x to the... Now remember my little trick. If the negatives look like they're following each other, your answer is negative because they're up to no good. And then add 6 and 9, so that would give you 15. Y to the 5 take away 1 is 4, and the z, 9 take away 12, is negative 3. Now again, when you see a negative exponent, your answer will be a fraction. So let's put our fraction bar, make this a fraction over 1. Let's start the eviction process. Who's being evicted? It's going to be the x to the negative 15 and the z to the negative 3. They must leave the apartment. So who stays in the apartment? The negative 4, because that is a coefficient. We only evict exponents. So the negative 4 stays, and the y to the 4 stays. The x to the negative 15 leaves the apartment, goes to the denominator position, and the z to the negative 3rd must leave the apartment, and that goes to the denominator position and becomes positive. And there's your answer. Negative 4, y to the 4th over z to the 15. Sorry, x to the 15, z to the 3rd. My brain is being evicted. Okay, last examples. So here I decided to combine the rules. We did product rule. That was my first video. Then we did power rule. And within the product and the power, I did negatives. And now I'm doing the quotient. So here I have 3 rules going on. I have power, product, and quotient. Now, whenever you have a base raised to an exponent, and then outside the parentheses you see another exponent, that is your power rule. And the power rule states, when you have a base raised to an exponent and raised to another exponent, you multiply. So this will be y 5 times 3 to the 15. And I'm multiplying by y to the 4, and I'm dividing by y to the 10th. When you see that fraction bar, it means divide. Now here I have the product rule, and the product rule states when your bases match, you keep your base and you add the exponents. So that will be y. 15 plus 4 is 19, and now we must divide by y to the 10th. Now this is where we have our quotient rule. And the quotient rule states when your bases match, you keep it, and you do 19 minus 10. So you have y to the 9th power. Yay, finished. Alright, I included an example that have coefficients because on Friday when we did this in class, my students were having a little bit of power rule malfunction, you can call it. So here I have 2 to the x raised to the 4th power all squared, multiplying by 3x to the 5th, and dividing by 6x to the 20th. So I have power rule, product rule, and quotient rule. Remember, power is always first because of PEMDAS. Exponents come before multiplication. Now you must remember 2x to the 4th raised to the 2nd power means that the 2 is raised to the 2nd power and the x to the 4th is raised to the 2nd power. And that 2 to the 2nd power is 4. And then here you would multiply 4 times 2, so that's x to the 8th power. So 2x to the 4th all squared is actually 4x to the 8th, which I'm going to multiply by 3x to the 5th, and then divide by 6x to the 20th. Now I'm going to do the product rule. Now remember, coefficients multiply coefficients. So the 4th, I'm doing it over here. So 4 and the 3 multiply each other, and the x8 and the x5 multiply each other. Now 4 times 3 is 12, and with the product rule, the exponents, you will add them. The coefficients, you multiply them because they're numbers. So 8 plus 5 is 13. And now I'm dividing by 6x to the 20th. Remember, when you divide, you go to heaven. 6 goes into 12 two times. The bases match, I keep. And I do 13 minus 20. Now I know that 13 minus 20 is negative 7. But negatives are not allowed, so we must start the eviction process. So who stays in the apartment? The coefficient 2, and the x to the negative 7 must leave in order to become a positive individual. So your answer is 2 over x to the 7th. I hope these examples have been helpful for you today. I've done all the rules, so check out those videos. I did product, I did power. Within those, I did the negative as well, and now I'm doing the quotient rule. So I hope these have been helpful. Good luck on your TASC examination. Like and subscribe.